Hey everybody, in this video we are going to find the sum of the terms of a sequence or series, and we are going to find an expression for a sequence. So here we have a series, and we're going to find the sum of the first 34 terms. First we need to decide if it is arithmetic or geometric. Now it's alternating between positives and negatives, so that tells me right there it's probably going to be geometric. So what I'm going to do is divide the second term by the first and then the third term by the second and see if I get the same ratio. 4.8 divided by negative 2 is negative 2.4, and then negative 11.52 divided by 4.8 is also negative 2.4. Okay, so we have a common ratio of negative 2.4. Okay, so to find the sum of the first 34 terms of a geometric series, we'll use this formula. The sum of the first n terms is a sub 1, so that's term 1, minus term 1 times the common ratio to the nth power, and 34 is n because we're finding the sum of 34 terms. And that's all over 1 minus the common ratio. So we have negative 2 as term 1 minus negative 2 times r, which is negative 2.4, to the nth power, n is 34, all over 1 minus r. So that's 1 minus negative 2.4. So I'm going to put this in my calculator all in one step. So I'll use parentheses around the numerator and then around the denominator. So we have negative 2, and I didn't even use the parentheses, so we'll start that over. Negative 2 minus negative 2 times negative 2.4 raised to the 34th power. And I'll close parentheses around the numerator, divided by the denominator in parentheses, 1 minus negative 2.4. And I get scientific notation. I'll round that to 4.97 times 10 to the 12th power. Next, we are going to find the sum of the first 83 terms in this series. Now this series, it's not alternating signs and it doesn't look like drastic changes, so I'm going to subtract term 2 minus term 1 and then term 3 minus term 2. So I have negative 111 minus negative 119, and that's positive 8, and then negative 103 minus negative 111 is also 8. So here we have a common difference of 8. So this is an arithmetic series. To find the sum of n terms of an arithmetic series, we do n over 2. 83 is going to be n here because we're looking for the sum of 83 terms, times a1, so that's term 1, plus a sub n, the nth term, which is the 83rd term. So I have here S sub 83, so that's 83 over 2 times the first term, negative 119, plus the last term, the 83rd term. So I need to find the 83rd term. So to find a particular term, we're going to do term 1 plus the common difference times n minus 1. So here we're looking for term 83, and that's negative 119 for term 1, plus a common difference of 8 times 83 minus 1. So that's negative 119 plus 8 times 82, and that is 537. So the 83rd term has a value of 537. So I'll put that right here. Okay, so what this does is it takes the average of the first and last term in the series and multiplies it by the number of terms. So I'm finding the average of these. That's what the sum here and divided by 2 does. And then we multiply that by 83 because we're looking for the sum of 83 terms. So 83 over 2 times negative 119 plus 537 is 17,347. So we have 17,347 as our sum. Next, we are finding the next 3 terms and then the 29th term. So in this sequence, we have x to the 5th, x to the 9th, x to the 3rd. That exponent is going up by 4. So then we have x to the 17th, x to the 21st, and x to the 25th power. Okay, but what about the 29th term? Okay, so what's happening here is we have a common ratio, so it's geometric, and we are multiplying each term by x to the 4th power to get the next term, because when you multiply with powers, you are actually adding the exponents. So our common ratio is x to the 14th power. So to get the 29th term, we will use this formula. A sub n equals a sub 1 times r to the n minus 1 power. So the 29th term, a sub 29, equals x to the 5th for a sub 1 times r, x to the 4th, to the 29 minus 1 power. Okay, so first we're going to do this exponent right here. So we have x to the 4th to the 28th. When we raise a power to a power, we multiply the exponent. So we have x to the 5th times 4 times 28 is 112. X to the 112th power. Then, when we multiply these, we will add the exponents, and that is x to the 117th power, and that is the 29th term. Next, we're going to write expressions for the nth term of a sequence. Okay, so what's happening here? 7, 10, 13, 16, we are adding 3 each time. So there's a common difference of 3. So this is arithmetic. For an arithmetic sequence, our formula will look like this. A sub n equals a sub 1, the first term, plus the common difference, times n minus 1. Okay, so we have a d of 3. We have a sub 1 of 7. So we have a sub n equals 7 plus d is 3 times n minus 1. So a sub n equals 7 plus, and then we'll distribute 3n minus 1. So a sub n equals 7 minus 1. And you see I have a mistake here. 3 times 1 is not 1. 3 times 1 is 3. 7 minus 3 is 4 plus 3n. Okay, so this is my expression. Next, I've got 2, 5, 12 and a half, 31.25. That does not look like we're adding the same every time, so let's divide. Term 3 divided by term 1. We get 2.5. How about term 3 divided by term 2? We get 2.5. And every time I divide a term by its previous term, I should get 2.5. So I have a common ratio here of 2.5. So this is a geometric sequence. In a geometric sequence, the formula is a sub 1. A sub n equals a sub 1 times r to the n minus 1 power. So a sub n equals a1 is 2, r is 2.5 to the n minus 1 power. Now we can't multiply these until we do this power. I have to do exponents before multiplication by order of operations, and I can't do this exponent because there's an n there, so I cannot simplify this. And our last one that we'll do here, we have 7, 13 over 2, 19 over 3, So what's happening here is that the numerator is kind of doing its own thing. The numerator has a common difference of 6, and then the denominator is doing its own thing. It has a common difference of 1. We've got 7 over 1, then 2, 3, 4. So a common difference of 1. So we have two different sequences to look at separately. So in the numerator, a sub n is the first term, which is 7, plus the common difference, which is 6, times n minus 1. In the denominator, we have a first term of 1, a common difference of 1, times n minus 1. And we're going to put the numerator over the denominator here. So we have 7 plus 6n minus 6 over 1 plus n minus 1. Okay, so we've got 6n and then plus 1. Okay, 7 minus 6 is 1, so 6n plus 1. And then 1 minus 1 is 0, so the denominator is just n. Okay, so our sequence looks like this. Our expression for the sequence is a sub n equals 6n plus 1 over n.